Hello, today I will be showing you how to access the College Scorecard API using Python. This is a really excellent data set containing information about colleges, universities, vocational programs in the United States. It's put out by the US government, and I thought it would be helpful to have a tutorial that shows you from start to finish, right, how to get information from this database and do a little bit of data analysis. Couple of prerequisites. This tutorial is going to assume basic familiarity with Python and Jupyter Notebooks, which is the environment we're using here. And before beginning this, you're going to want to go ahead and download this Jupyter Notebook. I'll put a link in the description. And sign up for an API key from the data.gov website. You'll go into this link, you enter your email, it's completely free, and they're going to just send you a magic number, right, that gives you permission to access the College Scorecard database. You should also go ahead and get the College Scorecard Data Dictionary from this link, and that is an Excel file that contains all of the names of the variables in this data set. We're going to need this later on when we construct our query and ask for particular information. So let's start by doing a couple of imports. We're going to import the requests library, which lets us grab items from the internet. We're going to also use Pandas, which is a very popular data frame interface for Python. And then there are a couple of optional ones I've added here that will be used to do some analysis later on in this tutorial. So just a little bit of background on the request.get function, which we'll be using extensively here. This is a function that tells Python to go download whatever is available at the URL that you feed it. So if I did a request.get on youtube.com and I stored the output to a variable called response, then I can call the directory method to see what methods are available on response, the directory function rather. So I called that function on response, and I can see that it contains a lot of information, cookies, right, raise for status, and a status code. This is probably the first thing I want to look at. So the status code tells us whether our GET request worked, and we got a 200, which means it worked just fine. The next place we want to look is probably the text. So this is like the contents of the web page. And if I look at the text of the YouTube web page, I get, right, some HTML. So this is the HTML code that your browser uses to render the YouTube homepage. If I do request.get on a URL that does not exist, right, then the status code will probably be different than 200. And in this case, it should be our 404 page not found error. So with this in mind, we're going to now use the request.get function to access College Scorecard data. So basically what we need to do is create a URL, and let me go ahead and show it to you. We need to create this URL, which is like an order, right, that tells the College Scorecard website exactly which data we want. It begins by simply pointing to the location of the College Scorecard database. That's right here in base URL. And then within this database, there are actually a few different data sets. The one that I will be showing you and that probably most people are interested in is the schools data set. So this is organized by institution. There are also data sets that break down student outcomes by field of study, for example. And then we will put a question mark right after that database, which says, okay, now I'm going to begin telling you the details of my query. At the beginning, I've put what I'm calling filter parameters. So this is saying of all the schools in all the rows, right, in this table, I'm only interested in the schools for which the size is in the range 25,000 and up. So I just want to look at pretty large universities that have more than 25,000 students. And so this was my filter parameter. And now I'm going to say of these schools, right, of these, the ones that the information that I want about those schools are these 9 items. So these are the things I'm asking for. I'm going to ask for the ID, which is a 6-digit number that just identifies the school in the database. I'm going to ask for the school's name. I'm going to ask for the size in 2 different years, the location of the school, right, in coordinates, and then the SAT and ACT math scores. And then just to show you what happens, I'm also going to try to request a random variable that does not exist. So I made a mistake here. The reason that I include this is that when you request a variable that does not exist from the College Scorecard database, it does not raise any warning labels or anything. In a context like this, it'll just simply return these 8 columns, and there will just be nothing here, right? So this is helpful to keep in mind because you might not notice until you've gotten a little bit further along that you're actually missing something because you made a typo in a variable name. And this is a good spot to point out that we need to figure out, right, exactly what fields are available. And this is where we will consult our data dictionary to build these field names. So the data dictionary Excel file, if I open it up, looks just like this. It starts with a README, but what we're interested in is this sheet called Institution Data Dictionary. This pertains to the schools.json dataset. And if I go in here, I will see a long list, right, of variables that are available in the dataset. So the most typical case are going to be variables that look like this, right? Admissions, academics, all of these are things that change from year to year. So if I think about something like my 50th percentile, my median SAT score, that's going to be different from year to year. And so if I want to know, say, the value of this variable for the year 2017, then I would need to type 2017 and then a period, and then the category, admissions, and then a period, and then the developer-friendly name. So my request would say 2017.admissions.SAT-scores.midpoint.math, right? So what you need to do is you put the year first, then the category, and then the developer-friendly name. Now, there are a couple of tricky things to bear in mind here. The first is that the year can also be replaced with the word latest. That'll just give you the latest year, and we saw that earlier. And the other thing is that there are a couple of special categories that behave a little differently than the syntax that I just explained. Those are school and root. So for schools, you just want to type school.name, and you will leave off the year. The school category contains information that does not vary from year to year, that's static. So for those, you leave off the year. And I've noticed that sometimes if you put on the year, it'll still work, but other times it'll give you an NA. So you want to be careful with that. The other thing is these ones in the root category. For those, you don't type any prefix at all. So you would just request simply ID or OP6ID, as it were. So let's go ahead and take a look again at the way I entered those fields. Here you can see that I asked for the student size from 2019. Whereas here, I didn't care exactly which year it was. I just asked for the latest year in the data set. Right now it's 2021. The latest year in the data set is actually 2019. And you can see that school.name, right, does not have that year prefix. Neither does the location information, and ID is all on its own. The next element of our query is what I've called options here. So this is basically how many rows do we want in each page of results. I think it's best to just set this to the maximum of 100 unless you're really requesting a lot of information. And then which of the pages, if there are multiple pages of results, you want to look at. So in our case, I've picked this filter parameter so that there will be fewer than 100 results. But if your query is going to return more than 100 schools, then you're going to have to repeat this request for page 0 and then for page 1 and so on until you start getting empty results. So that's an important thing to keep in mind, is that because you're limited to at most 100 results per page, in a real implementation of this, you're going to need to construct some kind of for loop that will advance the page count as you pursue more information. Finally, this is where we're going to write that API key that you got earlier in an email. So you will replace, right, this part of this string with the API key that you've signed up for. And in this case, I've gone ahead and hidden my API key in a text file. So if I run this cell, it will store my API key in the URL. But what you would do is just delete or comment out these 3 lines, put your API key in here, and then it'll incorporate it into the request URL. So all of this line does is it strings together, it concatenates all of these different elements, and it separates the fields by comma, as they should be. You can see that we have location.long, comma, latest admissions and AT scores, and so on. So this is our order. This is the URL that we're now going to send and request information from the data.gov database. So we're going to go ahead and try making our GET request. And what should happen if everything goes according to plan is nothing. We're just going to see an asterisk come up here, and then the asterisk will turn into whichever number is assigned to this cell. And that means the request worked just fine. Let's see what happens. Okay, so we had no problems. It means our request went through. Otherwise, we would see a red box and an error. Now, there are a couple of common errors that happen when working with this database that I thought I'd point out. The first one is the 404. So that's just if you made a typo somewhere, right? If your request URL is not correct. Another one that you get, especially if you're using a for loop to try to go through multiple pages or so on, or trying out different requests, is the 429. So this database limits you to 1,000 requests per hour, and if you exceed that, it will shut you out and you'll get this 429 error. So if that happens, you just need to wait. Well, if you wait an hour, then you're safe, right? Your count is reset and you can try again. Another one that happens sometimes is the 500. That means there's a problem on their end. And in most cases, if you just wait 10 or 15 seconds and submit your request again, it'll go through just fine. So now we have the result of our GET request stored in this variable called RESP. And what we want to do is convert this data into some sort of legible format. So what we got back from the server looks like this. It's a dictionary that contains some metadata, right? The total number of results and so on. But what we really are interested in are the results here. But this is not very legible. It goes on and on like this. And so we want to get this into some sort of table-looking object that will be easier for us to work with as analysts. So our information that we requested is in the results entry of this dictionary. And what we're going to do is feed the results entry of this dictionary to a Pandas data frame. And then I went ahead and changed the ID of the data frame to be the 6-digit college ID from the data set. You don't have to do this. If you leave this part out, then you will just get a numeric 0, 1, 2, 3, and so on index of the colleges. But this is a useful trick to use if later on you're going to want to join this table with another one that comes from the same data set, right? And you can see now that we have this nice table. It's omitted, right, some of the rows in the middle, but it contains all of the information we asked for. The columns come out in kind of a random order, but it's all there. And you'll notice that that typoed column that we made up earlier is simply silently missing. There's no warning about it. Another thing we can see is that for some schools, there's missing information, right? So for example, this university is missing a student size from 2014. It could be because it didn't exist then, or it's just missing for some other reason, but that's something we want to keep in mind later on when we start analyzing this data. Something that many of you will want to do at this stage is simply print this information to an Excel spreadsheet. And so if I use the Pandas feature to Excel, I can go ahead and save this to an Excel file right away. And if I go take a look at my current working directory, you'll see that that just generated a file called collegeinfo.xlsx, and they're just updated. You can go ahead and do whatever analysis you'd like to do in Excel there. However, I'm going to see if I can persuade you to stay in Python for a little bit longer and do a bit of data analysis using the tools that are built into Pandas and Python. So if we call the describe method on college info, we get a really nice statistical summary of each of the columns. So for example, we can see that the average student size was about 36,000 in 2019, right? We got all sorts of useful statistics there. We can also create a correlation table. So a couple of standout entries might be the ACT scores and the SAT scores for math. Both correlate very closely. That's probably what you'd expect, right? They're both math tests. And we can also see a correlation between the student size in 2019 and the student size in 2014, although perhaps not as strong a correlation as you might have expected. So if we make a scatter plot of our ACT and SAT math scores, we can see, right, this very strong linear trend. Makes sense. They standardize the heck out of these tests, right? And another thing we might want to do is some sort of statistical tests, right, on the data that's here. So what I've done here is I dropped NAs from College Info. So let me tell you in language what this means. For all of the information in College Info, this is going to look at the columns 2014 student size and 2019 student size. And if there's any college that's missing the 2014 student size, or is missing the 2019 student size, or is missing both, it's just going to leave that row out. So if I called this, that's what I would get, is the table without those rows. But now I want actually the index of this table, and I'm going to store that here so that this has size info variable contains essentially a list of the 6-digit IDs corresponding to colleges for which there was information about both the 2014 student size and the 2019 student size. So I've stored my index of which schools have size info here, and now I'm going to grab the 2014 student size and the 2019 student size and see if there was a significant difference, right, between the 2014 and 2019 class sizes. So let's go ahead and do this. I'm using the paired samples t-test. We got a negative test statistic, which suggests that there was an overall decrease, but the p-value was not super low. So we could say there's a statistically insignificant decline in the enrollment at large universities over the 5-year period. In actuality, these aren't samples from a larger population. This is the population of large American universities. So this is a bit of a toy example, but it's just showing you how you could perform a t-test using a Pandas data frame. Another cool thing that we can do is make a map. Let's see what happens. So here I've used some of the map plotting functionality that's built into the matplotlib library, as well as another library that's called Cartopy. So I've combined those two, and here we have essentially a scatter plot, but on top of a map of the United States, and I've sized each of the dots to show you how big that university is. So these are the universities in the continental US that have more than 25,000 students. Something weird is happening with the Great Lakes here, but if you're smart, you can figure out which colleges are which. So I'll let that be a guessing game for the viewer. All right, that concludes this tutorial. This is the first time I've made a video like this, but I thought that it would be helpful because I know that a lot of people working in education research want to access information from the College Scorecard, but are unfamiliar with using these kinds of command line based APIs to do it. So that was the motivation for making this. And if you have any questions or anything I can follow up on, I'd be really happy to make more material like this going forward. Thanks for watching. Leave some comments. Let me know how I can do better. And go ahead and grab this data and play with it yourself. Thank you.